Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial and get a sweet new t-shirt. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macey, and today I'm interviewing Dan Robinson about Heap and their approach to collecting, storing, and analyzing large volumes of data. So Dan, could you start by introducing yourself?
Hey, it's a pleasure to be here. Thank you so much for having me.
And wondering if you can just describe a bit about how you first got involved in the area of data management.
Yeah, that's really interesting. I've never really thought of what I do as data management, but that's actually a perfect description. When I was in college, I studied a lot of math and machine learning because I was really excited about all of the things that you could do with all these emerging data sets and all of the magic that people could build in the world, all of that promise. But when I came to actually do any machine learning, I had an internship at Google when I was in college, and I did some research projects. And whenever I came to actually doing any machine learning, all of the work was assembling data sets, munging data sets, and some amount of feature engineering. And all the classes I took were just math. They were proving bounds on convergences of different algorithms or proving bounds on error rates or things like that. And I guess I sort of came to think that the things that were bottlenecking all of this new technology were not actually stuff I was learning or working on. And all of the things that people were building that actually worked in the real world, I noticed this pattern that they had some sort of clever way of assembling a data set or some clever way of building the training set. But the resulting learning algorithms they used were pretty unsophisticated. They were the stuff that you learn in your 101 level machine learning class. So I got into this problem of how do you make these data sets actually useful? And the problems were really different. The problems are around actually building a data set that's correct or complete or that you can understand or that humans can interact with and iterate on or all of that good stuff. So my first job out of college was at a company called Palantir, which is solving a lot of these similar sorts of problems. You have these huge institutions that have hundreds of databases or hundreds of internal data sets, and actually building a unified picture on top of that is either for human analysis or machine learning is incredibly complicated, and it really requires some sort of abstraction layer. And then a couple of years later, I joined two friends at a startup that turned into Heap, which is solving a similar problem in terms of how you understand your customers.
And can you give a bit of a description about what it is that Heap does and how the project got started?
Yeah, so we make a tool for understanding your users. You might have a website or an app or anything like that, and we make a tool that makes it easy for companies to understand what people are doing in their products and around their products, like to get a complete view of your users and come to understand them better. So there are about a dozen tools that do something like this. They all work basically the same way, which is to say they give you an API and you can log events against that API. So that you might have some instrumentation in your product where you log checkouts and signups and views of a certain page or something like that. And all these products are really limiting for the same basic reason, which is that anytime you want to iterate on your analyses or track something new or understand something new, you need to go get someone to write new logging code and wait for the whatever Jira ticket you filed to get actually processed. And you have to wait for the code to go live and wait for new data to accumulate so you can actually do analyses and all that stuff. Your iteration speed is horrible. So the Heap approach to this problem is to capture everything that your users do and let you analyze it retroactively. So you include our snippet on your page or our library in your mobile app, and we capture every click and page view and form submission and text field change and tap and swipe and all of that good stuff. And then whenever you have a question, we already have the data, so you can answer it retroactively. So that means you can iterate on your analyses in the span of about a minute, as opposed to 2 weeks, or honestly at a large company, 3 months, 6 months, something like that. I think you asked about where this came from. Our CEO, Mateen, was previously a PM at Facebook, and that's a company that had the most sophisticated, Cloudera came out of there and it has the most sophisticated tooling in the world for doing analysis of your users and all of that stuff. And he ran into this problem that the things that he couldn't get answers to really basic questions. He was a PM on the mobile messenger product, and there were basic things that he wanted to know about how users were using this thing, or did they use this feature at all, or all of that stuff. And getting answers to those questions required filing a bug to get someone to log something, and then the data would show up in some schema that he really had no understanding of and tooling that was way too complicated for him to use. And the result was that they just made a whole bunch of decisions on basically gut, which is a real shame. You have this incredible Ferrari of a data processing ecosystem, and it was wasn't of value to a PM there who was trying to use it. So he eventually cooked up this idea of building an analytics product that captured everything.
Yeah, the ability to just automatically capture every interaction and every event out of the box is definitely very valuable, because having worked with some of the other tools, most notably Google Analytics, it can often be difficult to get things set up properly or understand ahead of time what it is that you want to be able to ask questions about. And so not having to worry about that when you first launch a project is definitely useful and very powerful in the end. And so given the fact that you do automatically collect every event, how do you prevent the user experience from suffering as a result of things like network congestion or delayed processing because of capturing all of those events and then ensuring reliable delivery of that data?
So the capture portion of this product is actually doing this right is one of the software engineering challenges of what we're building. A lot of work has to go into doing this properly. There's the first order stuff, like you don't want to overload the network on someone's mobile device or keep the network constantly active, because that'll drain their battery, and there's all sorts of stuff like that. So you have to do your basic batching stuff up and waiting for connectivity before you can upload it later and all of that good stuff. On web, iOS, and Android, there are different, I don't want to call them tricks, but really different solutions to this problem. But the commonality is that, yeah, it's really important in all cases that it doesn't affect the user experience at all. And that's something we were able to achieve. And then another portion of this is obviously on our server side, making a collection and ingestion layer that is rock solid, which just took years of iteration and work. A lot of the interesting work in there came late last year when we started doing Jepsen-style, Chaos Monkey-style testing of that layer, and we rooted out all sorts of little ways that data could get dropped, even tiny percentages of data. And the result is that we haven't lost a minute of data in the last 6 months.
Yeah, chaos engineering to be able to ensure reliability at the data layer, I'm sure, was an interesting challenge because of the sort of inherent nature of distributed systems and making sure that there's consensus and that you don't have dropouts and ensuring that there's appropriate back pressure, etc.
Yeah, all that good stuff.
Yeah, given the inherent complexity of a system like that, can you walk us through the life cycle of an event going from a user's browser all the way through to the end display of being able to process that data and visualize it?
Yeah, so an event is born somewhere in a tracker somewhere, or in either in JS that's on your web page or in somewhere in your app or something like that. It can come from a third-party source, and I guess we can get into that later. An event will be born, and it will be sent to one of our web-facing data collection services, which is a really lightweight Node.js app that receives this data and sends it to Kafka. And we can't drop anything at this stage because data is not persisted yet. So there's all sorts of logic in there to the effect of, if Kafka's not available, we'll spool it locally and re-ingest it later and all of that good stuff. But the data will sit in a Kafka queue until it is processed. We have a Scala ingestion layer that consumes from that Kafka queue and ingests the data into the distributed system that we've built to make these analyses work. So we have a distributed system built around sharded Postgres and Kafka and a whole bunch of Scala to make it possible to do the analyses that to make the analyses that we're trying to offer performant on this sort of product. So that's a distributed system that we've built around the problem of doing analyses that have this fundamental indirection between the raw data and the semantically meaningful data. So in a traditional analytics product, you log something, and all of the schema around that event is baked into the event. You log a checkout, and the thing that hits the analytics tool's servers is a checkout event with a bunch of properties. In Heap, what we're capturing are raw events. They're clicks or page views or form submissions or text field changes or whatever. They don't have any semantic value yet. And then in Heap, you create what are called definitions, which are basically predicates. A definition is something, for example, you would click a button on your site and say, this is the checkout button, and we'll extract from that various properties like the CSS of the button you clicked. And then we now have this label, a checkout, that we can apply to all of your historical clicks that match that definition. So then this is how that whole retroactivity idea works. You can define a checkout and then analyze all the checkouts that have ever happened going back to when you first installed this. But from a data engineering point of view, that means we're supporting analyses that are in terms of these definitions, which you don't know when the events come in, and they can always change. They're dynamic. We needed to build a new kind of distributed system to make it possible to do these analyses performantly. And you wanted to know the full life cycle, yeah. And then the read path is fairly straightforward. We have an app server that is built in Node as well, and we have a front end that's built in React and MobX. And you'll create some sort of analysis in our product, and you'll run a query, and our backend will turn that. Our app server will compile that into a query that our distributed system can support, and we'll run the analysis and give you your results back. And then two other important sort of destinations of this data. One is in warehouses. We have a product that we call Heap SQL, which you can think of as your Heap data set. You can think of as your Heap data set in a warehouse. So you might have a Redshift instance or a BigQuery cluster or something like that. And we offer a product where you can analyze your Heap data there. So you can do something like create this checkout event, and we will populate a table of all the historical checkouts that have ever happened, and you can run raw SQL on it. So then there's a separate destination that the data needs to go to. And finally, we are building out tech to do webhooks. So for example, you can set up a flow like when someone views this white paper, fire a webhook to this third-party tool and add them to this drip campaign, or ping me in Slack so that I know that they're doing this and I can take some sort of action on it. So the webhook activity is just an additional Kafka consumer that's evaluating these definitions on all the incoming streaming data. And I'm obviously eliding over some of the details. Like, one of the things that makes this very complicated is Heap has a really powerful notion of identity. I think an important pillar in any sort of data set like this is having a coherent notion of an identity, like what an actual end user is. It's not usually a cookie. It might be someone, an end user probably has components that are in different cookies because they sign on different browsers, and they might also have interacted with your mobile app, and they've also interacted with a bunch of third-party tools, like maybe they did a payment on Stripe, or maybe you sent them an email in MailChimp, and all of that data needs to go to one coherent user record so that you can do user-level analyses that make sense. So there's a layer in here that I've elided over, which is how these users actually get combined.
Yeah, that's definitely a complicated challenge in and of itself that we'll dig into in a minute. And going back to the beginning of the life cycle for that data, one of the most complicated aspects, at least in my experience, is ensuring the reliable delivery from the browser to the consumer, in this case, the Node.js application, particularly where you have things like the user might close their browser tab before the data gets flushed through, particularly given that you're batching it, or if the Node.js application is unavailable or they have a network hiccup, ensuring that the data gets flushed reliably and that you don't drop events that have been recorded in the user interface but not propagated yet through to the processing infrastructure. So do you have any particular tactics that you've employed to mitigate some of the issues there?
So our strategy thus far has been keep the server level really thin and really simple, and basically get it to the point where it never goes down. We have that set up to be multi-AZ, and we have a whole bunch of Jepsen style, like we've done a whole bunch of chaos engineering around making ourselves confident that'll never go down. On the client side, the problem of reliable outbound capture, which is what you alluded to. For example, if someone clicks a link on your site that takes them to another website, how do I reliably capture that as they're leaving or as they close a tab or all that stuff? That does turn out to be a very hairy, very tricky problem. It's actually a problem that we have noticed a lot of people get wrong when they instrument their own websites in the naive way. Every other tool requires you to write basically click handlers that track the things that you care about. And if you just naively throw a click handler on this, you'll lose like half the data because people the browser will have closed and navigated away before your thing is received. So we do some trickery in the tracker to make sure that we handle all of those cases and reliably capture stuff as you're leaving a page or closing a tab or something like that. And I think a big part of this is just doing the work to get the software engineering like doing the software engineering work and being diligent about it. We have a pretty extensive suite of the tests that we run against our tracker to cover all kinds of different OSs and browsers and combinations of those things. And it's a core part of what we do. Like there are two main things. This thing cannot lose data. It needs to reliably capture, even if there's some kind of network hiccup or some sort of weird user behavior on the site or some kind of bizarre crime against the DOM that somebody does on their product. And also, it cannot break people's websites. And if you get too tricky with what you're doing in these things, it is possible to break people's websites. That's not something we've really done in years, but in the very early days of this product, we learned about all kinds of different subtle ways you can affect people's products in a bad way. It needs to be an incredibly well-tested piece of code in this product.
Yeah, particularly in the context of browsers, it can be a very messy and chaotic environment because of things like browser plugins that inject various bits of JavaScript and some of the weird hacks that people will do on their websites to modify the DOM. And so I'm sure that it creates a fair bit of noise in the events as you're tracking them. So what are some of the ways that you have built up to ensure that the data that you do track has proper integrity and accuracy, and I'm assuming that there's a unified container or representation of that data to allow for ease of processing on the back end to ensure that you can merge events appropriately and have some sort of commonality between the data points to be able to do an appropriate analysis on them?
Yeah, we don't generally do anything particularly fancy with the browser. We're not building something that does we're not building something like Full Story that does session replay. So we're not trying to re-represent the DOM within the layer that we operate. There's surprisingly little variation between the browsers, and it's usually in an area that third-party extensions and et cetera don't affect too much. And at this point, we only support IE8 and above, so it's at least somewhat sane. But of course, whenever I think this is mostly just a question of diligence. Like, you have to be very careful and write the tests and handle all of the possible things that you've ever seen come up. We've seen things from particular JS libraries that someone has on their page, breaking something, or a particularly weird use of SVG, or all kinds of weird stuff like that. And we have a pretty large free tier, so just an enormous breadth of different websites. So we've seen a good chunk of what the internet will throw at this kind of tracker. And I think it's just a question of doing the work, like encountering a thing like this, treating it as a top priority to fix, writing a test so that you never have that issue again, and rinse and repeat.
And in terms of the data representation, do you have some standard unit of data that you ship to make it easy to integrate the information at a later point between the various browsers or websites that somebody might have and mobile applications?
So we have a standard, in Heap, there are users who have sessions, and sessions have many events. And we have a standard, I think the first layer of this is that we have a standard event schema for all of the events that we capture. That includes across third party. And then the identity piece of this is, I think, where it starts to get really interesting. The way that we handle this is we give users an API that lets them basically specify tags or handles that go on a user, or identities, and we'll combine different users that see the same identity. And what's cool about this is that you can represent a really complicated user flow doing this. So for example, you might have an e-commerce product where users do guest checkouts and they enter their email when they do so, or they sign up and they have some identity that's part of your system. And Heap lets you effectively create a graph of different components of users where edges reflect having a common identity at some layer, like having these two users have the same email, or these two users have the same Stripe ID, or these two users have the same identity, or something like that. And we will combine all of those users in basically each connected component in that graph into something that looks like one user to you. So this is maybe an overcomplicated way of saying we give you APIs where you can tag users with various properties and specify that if two users have the same value of this property, they should be combined. And under the hood, we're doing a whole bunch of manipulations of this data so that when you run analyses, it looks like those are just one users. So to a person running analyses in this product, when you run a conversion funnel that has data from 4 different sources, like I want to see a conversion funnel between sending someone an email from this campaign to usage of this feature, and percentage of those users who later added something to cart, and percentage of those users who later paid via Stripe, to an analyst using Heap, or to anyone asking a question in Heap, it looks like it's just one user. And I think that's really important. All of the really interesting analyses are at the user level. So that's a big part of what we're trying to represent.
And what are some examples of some of the third-party integrations that you support and some of the complexities that introduces to your infrastructure and your capabilities for being able to ingest data and merge it together with the data that you're collecting from the event trackers?
That turns out to be a really interesting question. Basically, doing a good job handling third-party data is really a full stack problem. There are product portions of this, like you need to make it, you are now building an analysis product where events can come from n different sources instead of just your main product, or they can come from n different sources instead of just the website itself or the iOS app, and you need some way to communicate that to users so they understand what they're looking at. Then there's also the problem of doing the data capture. All of these tools have their own APIs. I think the thing that makes it particularly interesting is that they all have their own semantics. Like, tool number 1 fires a webhook at you when an event happens and you need to receive it. Tool number 2 has an API where you can crawl it and get a CSV of the last hour of events. Tool number 3, Salesforce is a particularly interesting one because one way to handle it is to deploy an Apex plugin that your user installs into their Salesforce instance that spits data at the Heap server. Or another way to handle this is to crawl things against someone's Salesforce instance using the Salesforce API, but then you run into problems around the cost of doing so because customers pay by the API use of Salesforce. So all of these tools have their own weirdness, their own semantics, and managing all of that is a pretty considerable challenge. And then the infrastructural challenge under the hood is really one of data integration. Basically, you have users in n different products, and there's generally no global identifier that ties all these users together. So our solutions problem has been, for each of these sources, you select some sort of identifying field that comes from the source. Like Stripe events have an email address or a Stripe ID or a couple other fields. And you'll pick one of those fields and you'll match it up against a corresponding field that your users have that you're already supplying as a user property, like the email, or you might have been sending in the Stripe ID or something like that. And we will do that join under the hood. Doing that join turns out to be really complicated because we do it at write time. We persist those changes in our data store so that at read time, the analyses are really fast. But that turns out to add a considerable amount of complexity.
Yeah, and one of the challenges there too is that it ties into the conversation that's been happening a lot in the data engineering space lately of ETL versus ELT in terms of when do you do that transformation and how does that impact your ability to do future analyses or retroactively change the way that you apply some sort of semantic meaning to the raw data. So it's difficult to decide when you want to make those changes, and particularly when you're dealing with large volumes, you don't necessarily have the luxury of just having it both ways of load the data into some raw archive and then also transform it in one of the storage systems so that if you then do need to go back and change the way that you're processing it, you can just reapply it from the raw storage.
Yeah, I mean, in some sense, this is the problem of Heap, where we're building a product here that to a user feels like schema on read, but from a performance point of view needs to, under the hood, do a whole lot of schema on write type stuff. We are giving you the flexibility to say that a checkout is actually not this click, it's actually a little subtler than that. It's this or that or this other thing, and then we need to instantaneously update all of the raw events that we've captured that were checkouts are not necessarily checkouts anymore. You might at any point in time add a new definition or add a new event that you're interested in analyzing, or change one of those definitions or merge some of them or something like that. And to you, that's a schema on read experience. You're deciding when you're doing the analysis how you want that data to be shaped. But from a performance point of view, these data sets, there's a petabyte of data in this product. These data sets are way too large for us to be able to actually lazily do that. So we need to do a whole bunch of hoop jumping. But I think that's, in a fundamental sense, what we're building. I think what's needed here is an abstraction layer between what is captured and what is being analyzed. That's really what we're building. We're building data virtualization. When you build an application for a desktop, you generally don't code in terms of the underlying drivers. You have an operating system that abstracts that away for you. Or when you use a browser, you don't punch in an IP address, you type in a URL, and we have DNS that actually handles that indirection. And data sets should really be the same way. I should be able to change the configuration of my data set or change basically my schema and have the data set retroactively update. I should be able to say, actually, I want to change my event schema. I want to additionally include this event, or I want to additionally include this property, or I want to remove this property because that's a PII concern, or I want to change how data is joined between my Stripe data set and my Salesforce data set, or I want to change how users are combined between my different subproducts, or all of that stuff, there should be a capture layer that captures a raw data set that is complete and totally automated. And there should be a configuration layer that you can modify at any time that determines basically your schema, determines your event schema and how your users are combined, your user identity schema, and all that stuff. And that should produce for you a virtual data set, or a synthetic data set that you then run analyses in terms of. So you should be running analyses on top of this abstraction, and under the hood, it should just handle all of that schema complexity. Basically, that's the product that we're building. This is data virtualization software. This is software that gives you the power of schema on read, but the performance of schema on write.
As you've grown the business and your customer base, and at the same time the volume of data that you're working with, what are some of the problems that you've had to deal with, and some of the architectural changes or evolutions that have been introduced by necessity because of this increase in scale and complexity?
First and foremost, we've had to do a lot of work on that analysis layer that I described before. We have an in-house distributed system that we've built on top of sharded Postgres, and scaling that out, multiple orders of magnitude over the past couple of years has been an enormous amount of work. So a lot of the work there has been really within the Postgres layer, experimenting with different hardware and different configurations and different file systems and different schemas and different ways of expressing these analyses and all of that stuff. So first order, there's a databases at scale problem here. Another general sort of trend that we've had here is that we are giving our customers more and more complex ways to model their data, or the ability to model more and more complex data sets, like more complex notions of identity, or more complex or richer data sets, or adding third-party sources. These are all additional complexifying factors. So the number of distinct areas of our infrastructure has grown considerably, even in the last 18 months. Even in the last year and a half, really.
And what are some of the changes that you are anticipating needing to make as you continue to bring on new users and increase the volumes of data that you're dealing with?
A lot of the work that we're doing in 2018 is around scaling out the product that we offer to enormous customers that have websites that are, in the hundreds of millions of sessions a month, some enormous product like that, and allowing the underlying components of our infrastructure to specialize. So what I mean by that is, we currently have this distributed system that we've built on top of sharded Postgres, and it is really good at supporting the analyses in the Heap product. So running conversion funnels, or graphing instances of an event per day, or unique users who did an event, or things like that, or cohorts and all of that good stuff. But there are a lot of other uses of this data in this product, where we populate data sets in people's warehouses. There are real-time use cases that it doesn't serve well. There are more advanced use cases like more advanced statistical learning type stuff that people want to do on top of this data set, and features will want to support there. And the system that we've built is really, really good at one thing and not really very good at these other things. So we're building a lot of new stuff right now to handle various different portions of this. So for example, we're building a separate S3 store for all of this data that will power future warehouse use cases. This will allow us to support Heap SQL customers that are 100 times as large as customers today for a 30th of the cost. There's some incredibly improved performance like that. So that'd be an example of pulling out the persistence and the warehousing use cases from this data system that we've built and letting it focus on the thing that it's good at. So I think when people at startups generally talk about things being monolithic, they're talking about their app layer, which does too many things that they split into microservices. I think this doesn't necessarily apply to Heap, because our app is still monolithic, and that's been totally fine, because it's not fundamentally that complicated. But the underlying data system is fairly monolithic, and we're splitting that out into a bunch of different data services that are not necessarily all that micro, but at least sharded out by function. So that's a lot of the work that we're doing right now. And another large area of work for us is building out more of a platform and allowing people to use this data in much more flexible ways. Right now, we have an end-to-end analysis solution that is very powerful, but this data set that we are allowing users to create, this virtual data set, is really powerful and useful for all other kinds of stuff. There are a lot of other warehouses that people want to use this in and join it with other information downstream and run advanced things there. There are machine learning models people want to train. There are real-time use cases, like a webhooks type use case. So building out the underlying data platform so that we can support a much more flexible set of use cases is another big area of focus for us right now.
And digging a bit deeper into the difficulties and complexities of offering the synchronization with users' data warehouses. I'm wondering if you can talk a bit about the architecture that you needed to build out to ensure that data synchronization doesn't cripple the end user experience of people who are doing interactive queries or visualizing the data on your end user portal.
Yeah, so I mean, that's largely a question of capacity engineering. Building a Redshift destination for this data has been a really interesting experience. And I think the underlying difficulty here comes from the fact that the underlying data model in Redshift and the underlying data model in our analysis layer are just very different. So supporting things like a really complicated notion of user identity that unfortunately makes the data mutable, for example, is something that's very tricky in Redshift. So we've had to iterate quite a bit on how we want to represent that. And then another sort of interesting set of problem areas around supporting something like this is that because Redshift is halfway between infrastructure as a service and a platform as a service, like I think you can think of Redshift as like 20% of the way to on-prem. So there are just a lot of environmental factors that are not under our control that make it easy for a customer, for example, to accidentally break their own heap SQL experience. For example, if a customer changes some sort of security configuration or a networking configuration, we can no longer access their cluster. Or if they toggle on a whole bunch of new data that they want to send to their heap SQL cluster and they don't actually have enough space for it on the other end, there's all sorts of sort of problems that you can run into here, and then just factors that are not under your control. This is in contrast to something like BigQuery, where we haven't seen nearly as much of that. I don't want to say idiot proof. I think the real thing is that it's just more of a platform and less of a piece of infrastructure.
And what have been some of the most interesting challenges that you faced or lessons learned while building the technical and business aspects of Heap?
That's a really interesting question. I think from a business point of view, one of the interesting challenges is, and you may have already heard me struggle with this a half hour ago, is it really explaining what we are. In a kind of fundamental sense, we are building data virtualization. That's what this is. We're building the ability to capture and control and organize a dynamic, synthetic, virtual data set. That's not a category that exists. That's not something people are looking to buy because it's not out there except for Heap. So it's a new idea. So I think something that we've really struggled with, and I think something that we've really wrestled with over the last couple of years, is how to explain this thing. You can describe it to people as an analysis tool, and it is a much better way to do user analytics than other tools on the market. But that sort of undersells what this is for. That puts it in that's a kind of narrow. That is one of many possible applications of this data set that is possible with Heap. But on the other hand, if you don't map it to something that people already understand, then you're sort of inventing a category, which is really hard to do as a 100-person startup. So really figuring out exactly how to position this and how to explain it has been a challenge. I think the flip side of that is that when people understand what this is and they buy it, they love it. Unfortunately, I'm not going to get into numbers right now, but our churn and our expansion, our upsell are extremely strong. Like those are, for a SaaS company, I think we do off the charts in that area. And part of that is we have a really talented, hardworking account management team, and they do an excellent job. But another part of that is that the fundamental product here is very powerful and useful, and people will use it, and they want to buy more of it when it comes time to renew. Or they start using this, and they really don't want to go back to tracking plans. If you're not deeply into the space, a tracking plan is like a big spreadsheet of all the things that you're going to track, and it's supposed to list all the things you'll ever want to analyze, and of course you miss some things, and it's an insane, arcane way of doing this. No one wants to go back to that when they start using Heap. So I think we have this interesting challenge, and that is hard for us to explain to people what we do, and it's a hard conversation to start, and the person who would buy this at different companies is often very different. But once people do start using this, it's incredibly sticky and powerful, and they want to keep using it. So I feel generally, obviously, I feel really optimistic about the company. I think this is one of the reasons that this is a problem kind of messaging and educating the market. And I think that's a lot more solvable than if our product did not have some sort of fundamental fit. Like I would rather solve the problem of educating the market about why data virtualization is so powerful and why they need it than have something that people already know how to think about, but it's not actually that valuable, so that when they end up churning off of it. From a technical point of view, a lot of in some sense, the whole product is technical risk. Like what attracted me to joining the company is that it's enormous technical risk and I thought relatively low product risk. It's it's a clearly better way to do analysis. Why would you ever want to? It's kind of silly that the way we do this in other tools is we whitelist the things that we want up front, which is crazy. Of course you don't know the things you want. All the interesting stuff is in the unknown unknowns. But it's a really high technical risk. It's a kind of product that, scaling this to enormous data sets, scaling the data capture, scaling the analyses so that large customers can use this in an interactive way, making this cost effective. All of that stuff is really challenging. Another area of challenge for us is this is sort of unique as analytics products go in that at a lot of our customers, there's a lot of different producers of data. In analytics, there's this idea of producers and consumers. You have in most analytics tools, there's a small number of people who create reports, and then there's a large number of people who view dashboards, that consume reports, basically. In Heap, the fact that this product, in some sense, the fundamental power of this is that it unblocks people. They don't need to talk to IT or engineering or whoever to get data that they need or to get access to something, because it's already all there. It's already all captured. But that means we're building an analytics tool that has tons of producers and tons of consumers, which is different. And that exposes all kinds of new problems that we've had to wrestle with. But yeah, I mean, anything where you're dealing with this kind of data scale when you're trying to run 2-second analyses on a petabyte scale data set, like everything's hard, I think.
And I'm sure that it wasn't made any easier with the current, actually just today, beginning of enforcement of the general data privacy regulations from the European Union. So have there been any significant changes necessary in your product or your processing or in any of your messaging to account for that new regulation?
That's right. Happy GDPR Day. It's my everyone's favorite holiday. It's been surprisingly little from a technical point of view. We were already SOC 2 compliant, which meant that we had a lot of the bones in place to comply with most of the portions of this law. Like, we're already, first of all, a lot of this law is stuff that you should be doing anyway. Like, you should be reporting incidents to authorities. You should be making a reasonable effort to create. You should be making a reasonable effort to create, to do least privilege type access internally in your systems, all of that kind of stuff. And then a lot of it is stuff we'd already been doing for SOC 2. I think this adds a lot of work for controllers, which is really for our customers, because they have to acquire and manage a whole bunch of different, consents and all of this stuff. But from our point of view, it's less than you would think from a technical point of view. Obviously from a processes and business point of view, it's an enormous amount of paperwork and signing and managing all these data protection agreements and signing and managing all these DPAs and all that stuff. It creates a lot of work. I think the main technical change that this has provoked is that we need some notion of deleting. We need some way to delete users. Our customers' users might revoke consent for processing of data, and they need to notify us via some sort of API, and we need to delete that data. And this turns out to be really difficult. And this can turn out to be more difficult than it seems, because I think in any distributed system, deletion is one of the harder problems, because like in something like the Heap backend, data about users exists in like 50 different places. It's in various different Kafka topics. It's in various different buffers and caches and downstream warehouses that our customers have it's in our analytical store, all of that stuff. I think the problem, so deletion can turn out to be very tricky, is in Heap, one of the things that has made it a lot easier is that we already have such a robust notion of identity that actually under the hood has turned out to make it a lot easier to manage deletion. So what I mean by that is, if you need to delete all of the information that you have, delete or anonymize all the information you have about a particular user, the fact that we have a whole bunch of tech already to manage the complexity of this web of user relationships meant that this is actually surprisingly easy for us to implement. But it's definitely a pretty major change. I mean, previously there wasn't really any kind of first-class way to do this. We have tools for deleting PII if you accidentally send us some, but that's sort of a different problem. That usually means deleting a certain property from all of your events, which is different than deleting an individual user or something like that. But yeah, it's been obviously it's an adventure for everybody, and I think the next couple months will be really interesting as we find out how this is actually going to be enforced. And I think it's an interesting law because it leaves a lot up to interpretation, which I think is really smart. Like, I think if you write this kind of law and you're very specific about what the rules are, then the law is going to be really outdated and silly in 2 years because the technology changes so fast. But the way that the law is written, it obviously has this trade-off that it's very vague. So I think it'll be really interesting in the next couple of months to find out how this is actually going to be interpreted and enforced. But thus far for us, from a technical point of view, it hasn't been as bad as you'd think.
And what are some of the plans that you have for the future of Heap, either in terms of new features or capabilities, or new business directions, or just general infrastructure improvements?
There's a couple different directions here. One is continuing to double down and triple down on that capture layer, handling more different kinds of ways that data gets created. We still don't support React Native, for example, and there's all kinds of third-party sources that our customers have data in that would enable valuable analyses in Heap. There's also the obvious infrastructural problems of scaling to bigger and bigger data sets, to scaling to customers who are doing 100 million sessions a month or more than that. That brings its own challenges, and that's something we're working on right now. And as I mentioned before, I think building and selling more of a platform that lets you do a whole bunch of different things with this data and less of a monolithic analytic solution, it's going to require a whole bunch of changes for us from a technical point of view and obviously from a business point of view. These portions are pretty exciting to me. And then there's a lot more to be done in making it possible to interact with this data set, in making it possible to iterate on this data set. I sort of described this idea of data virtualization, that there should be some virtual or synthetic data set that is constructed based on some raw data sets that we capture and some configuration that you specify. Right now, we virtualize the event schema. You can define your events at any time or change your event definitions or anything like that, and Heap will automatically update your warehouse as if you'd been tracking it that way from day one, and update your analyses in the next, you can run a query 10 seconds later and your analyses will be updated. So the event layer is already, the event portion of your schema is already somewhat virtualized in Heap, but there's a whole lot more that we can do here. There's we have the most powerful tools on the market for representing a complex user flow, for representing users that have in a product that has a different notion of identity at different stages. Like I mentioned, you might have customers who supply an email when they make an anonymous purchase, and then they actually log in later and they make a logged in purchase, and you want to correlate this. This is the only product that lets you represent that properly. But even then, we don't let you do it in a retroactively modifiable way. We don't let you do it in a way where you can change the definition of a user and it will be as if you had it that way since day one. Right now in Heap, it's still something that you need to write code for. So making it possible to virtualize all of this stuff and make a truly virtual data set, I think or over the next few years is going to require a substantive amount of work. I think one of the things that makes this space so interesting to me is that it is so clearly nascent. Like, it's so clear that the data tech that so many companies use is just garbage. It's horrible. It's so hard for smart people who are spending a lot of money to answer basic questions or to build basic things. Nothing talks to anything. Like, no one can understand these data sets. The problem of getting to the point where you actually trust your data set and it's correct is incredibly difficult. That's usually most of the work. People spend 80+% of their time just iterating on the data set, trying to get to the point where they trust it and it makes sense and it's correct and they understand it. And you have these data teams who are really, in a lot of places, like glorified knowers of the schema. They're glorified query compilers who can actually run an analysis or something like that. They understand which columns are correct and which aren't correct. All of this is going to look ridiculous in 5 years. It's so absurd that this is the technology that we use to make decisions. And I think the thing that will make this look so crazy is when it doesn't look crazy to go to work in a car until you realize that there's, until jetpacks get invented or something like that. I think when data virtualization is a widely used, widely applied technology, that'll solve a lot of these problems. You'll have a virtualization layer where you can understand what your data set actually means, that can explain it to you, that can proactively tell you things about its correctness or anything like that. So, this is what we're building. I think this is the data infrastructure that companies need. This is the decision infrastructure that's going to make it possible for companies to do more complicated things at scale and serve their users better. But that's obviously, I think what we do right now is 2% of what we'd like to do.
So for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And you already talked a little bit about this, but from your perspective, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
Yeah, I think it's that lack of a virtualization layer. I think people are building really powerful tools that solve the easy parts of this problem. People are building tools that let you run Hadoop jobs over bigger and bigger data sets, or shinier and shinier visualizations, or analysis front ends with more bells and whistles. But the underlying problem is that is the data provenance, is the data integration. People don't have a complete data set. They don't have the event they needed tracked, or they don't understand what checkout step 2 means, or they don't know if they can trust all these different things. They don't know if they can trust if they should be looking at the price column or the amount column. Those, I think, are the interesting and hard problems here. I think that's what will actually unlock all the value of this stuff for businesses. That's what strikes me as just egregiously missing, and that's obviously the problem we're trying to solve.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you're doing with Heap. It's definitely a very interesting product, and one that I just started using while I was doing research for the show. So I'm looking forward to interacting with it as you continue to grow the business. So thank you for that, and I hope you enjoy the rest of your day.
Thank you so much for having me. This is a pleasure.